This is going to be a real short video on components of blood pressure itself. When we are measuring someone's blood pressure, there's really three things that we can be looking at. The blood pressure itself, something called the mean arterial pressure, which we can calculate, or hopefully our non-invasive blood pressure machine will calculate it for us, and then the pulse pressure. So blood pressure is cardiac output multiplied by peripheral vascular resistance. And really, we just think of this as the pressure that's in the blood vessels that's circulating throughout the body. Normally, or desired, is 110/70. These are new guidelines that have just come out. We say the average is usually about 120/80. They've lowered it a little bit, so that means more people are going to be considered hypertensive or high blood pressure. But they've been showing that the lower the blood pressure, the less risk of heart disease and stroke later in life. The systolic blood pressure, or the top number, is a measure of how strong the ventricles are contracting. So that number is when the ventricles contract. And when that happens, there's a pressure wave that goes out through the arteries, and that's what we are listening for or feeling for when we measure our blood pressure. The diastolic blood pressure is then when the ventricles are relaxed and the ventricles are filling back up with blood. And this number, or this pressure, is the pressure that's in the arteries basically all the time, even when the ventricles are relaxed and there's no extra pressure. And that's why the diastolic blood pressure is such a concern when dealing with high blood pressure. If the diastolic pressure is high, even just a little bit high, the arteries are more likely to be damaged. Hypertension is anything that we say, or anytime that we measure something greater than 140/90. Now that's just, when we take a blood pressure, it's just one measure. Typically, to be diagnosed with hypertension, you have to have multiple readings of greater than 140/90, or either one of those could be high. Now, when we go the other way and we say somebody is hypotensive or maybe going into shock, we typically think of that as a systolic blood pressure of less than 90. So blood pressure is cardiac output, which is the amount of blood that is pushed out of the heart in a minute, related to the peripheral vascular resistance. Peripheral vascular resistance is the resistance that the heart must generate to overcome the blood that's there, or to overcome the resistance to moving the blood. So the blood vessels are constricted, or at a certain diameter, and we have to overcome pressure to move that. If we become more constricted and our peripheral vascular resistance increases, then our blood pressure increases. So as we constrict our peripheral blood vessels, our blood pressure goes up. Now, this mean arterial pressure is trying to come up with a single number for blood pressure. So it's kind of an average of the blood pressure during a single contraction or cycle. And we use this a lot, maybe not pre-hospital as much as they do in hospital, but it's kind of an effective way to determine if organs are getting enough blood flow or not. On the average person, we see a mean arterial pressure of 65 to 110. When we're dealing with patients that might be going into shock or having low blood pressure, if we can keep a mean arterial pressure greater than 70, we're probably going to have good perfusion to the organs of the body. This is how it's calculated. So your mean arterial pressure is equal to your diastolic pressure plus 1/3 the difference between your systolic blood pressure and your diastolic pressure. So let's take a look at this. If I had a blood pressure of, let's say, 110/80, well, the difference between 110 minus 80 is equal to 30. If I take 1/3 of 30, I get 10. And then add that back to my diastolic blood pressure. So I get 80 plus 10. So I would have a mean arterial pressure of 90. Not really all that hard to do, but our machines can do it almost instantaneously for us, and that's kind of nice. Now, pulse pressure is that difference between the systolic blood pressure and the diastolic blood pressure. So if I had a blood pressure of 120/80, I take 120, I subtract 80 from it, and then 40 would be my pulse pressure. As we go into shock, and we have peripheral vascular constriction, we see our diastolic pressure begin to rise. So it might be like 120 over 80, and then as we start to go into early signs of shock, we might go 120 over 90. So then our pulse pressure becomes 30. That's less than 40, so we'd call that a narrowing pulse pressure. Now, if that pulse pressure gets to be less than 25% of the systolic blood pressure, then we really begin to think that we have somebody that's going into shock. We call it abnormal. And there are some concerns with pulse pressures being too wide also, but that's usually beyond what we're doing in EMS. So a little overview on pressures. Hope this helps.